Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Eti Puspitasari from State Polytechnic of Malang. Now I would like to present about my research with the title Effect of Material Type, Temperature, and Layer Thickness on PLA and PETG from 3D printed products by tensile test. Introduction. 3D printers are one of the current and future technologies that must be studied, where the science of reverse engineering is developing. 3D printers are very practical in product development to print three-dimensional objects such as parts for prototype, machine part, robotic parts, electronic circuit parts, and other plastic products. You can see in the image below that this is 3D printer process, and then this is example from 3D printer product. As a designer, must know the proper material in terms of material strength, time, and cost. Some of the literature review about prototype product with printer 3D and previous research on 3D plastic material can be seen below. My research purposes are to analyze the effect of material type, temperature, and layer thickness on the tensile strength of 3D printed product with PLA and PETG materials. Analyzing the effect of interaction between material type, temperature, and layer thickness on the tensile strength of 3D printed product with PLA and PETG material, and able to make 3D design and prototype of 3D printed product from the research results that have been obtained. Methodology. Research methodology can be seen on the research block diagram. Independent variable has three variables, are material type, temperature, and layer thickness. And control variable has four variables, are printing speed, infill pattern, full fill density, bed temperature. And then we process on printed 3D. And then the point variable is tensile strength. Then we can make product design and product manufacturing with 3D printer. My research hypothesis is there is an effect between material type, temperature, and layer thickness on the tensile strength of 3D printer product made of PLA and PETG material. And then data processing and analysis method, drawing the tensile test specimen, drawing software and save in STL format. Then the data is entered into Cura for data processing according to above variable and then convert into a G-code file and then print it using a 3D printer and then tensile test and then processed by factory design and make product designs and manufacture product with a 3D printer. Result and discussion. First, we draw specimen design 3D tensile test standard ASTM D638 and then setting specimen parameter with Cura and then converted into G-code file. And then G-code file we can transfer for 3D printer process. And then this is result of tensile test specimen from PLA and PETG from 3D printer. This is all of result of tensile test specimen. And then next process is measuring the PETG tensile test specimen from 3D printer with a vernier caliper. And then tensile test process of 3D printer, and then this is a tensile test result of PLA and PETG specimen from 3D printer. In this picture show that the normality probability plot shows that the data is on the normal line and approaching the diagonal line. So it is stated that the data is normal. And after that, we make a main effect plot of tensile stress. The maximal tensile strength for this type of material is at number 1, namely PLA, while the lowest is at number 2, namely PETG. The highest maximum tensile strength, the temperature, is achieved at a temperature of 260 degrees Celsius, and the lowest is at the temperature of 220 degrees Celsius. It can be seen that the higher the temperature, the greater the effect on tensile strength. And the highest layer thickness for maximal tensile strength is at layer 0.3 millimeter, and the lowest is at a layer 0.1 millimeter. It can be seen that the thicker the layer, the greater the effect on tensile strength. And result and discussion. Next, the interaction plot between material type and temperature and layer thickness shows that the highest interaction between material type and layer thickness in type 1, namely PLA, with a layer thickness of 0.3 millimeter. The highest temperature is at a temperature of 260 degrees Celsius. And after that, we can process with a counter plot of tensile strength. You can see in the picture that the area that has large tensile strength on this area more than 4 Newton per millimeter square millimeter is at layer thickness of this and temperature between 240 until 255 degrees Celsius. Furthermore, the area that has the small tensile stress of 1 until 2 Newton per square millimeter, with a temperature between 220 degrees Celsius. This is a layer thickness. From the research about above, the best tensile strength for PLA material with layer thickness of 0.3 millimeter and temperature of 260 degrees Celsius. From this result, the researchers make an additional hanger for a motorcycle design and will then make a prototype printed on 3D printer as shown in the image below. This is a 3D design of additional hanger for a motorcycle. After that, we printed 3D result of additional hanger for motorcycle. And this is application of additional hanger for a motorcycle can increase the capacity to carry goods on a motorcycle. The background for making this design is the application of the research result obtained where the product to be made contain element of tensile strength because the function of the product is a hanger of good where it accepts loads and tensile force. Conclusion. There's an effect of material type, temperature, and thickness on the tensile strength of 3D printer product with PLA and PETG material. The hypothesis each one is accepted, supported by the factor design method where the p-value of the 3 variable is less than the value of 0.05. The maximum stress is on the type of PLA material while the lowest is on the PETG. The highest maximum tensile stress temperature is achieved at a temperature of 260 degrees Celsius and the lowest is at a temperature of 220 degrees Celsius. It can be seen that the higher the temperature, the greater the effect on tensile strength. And the highest layer thickness for maximum tensile strength is at layer 0.3 millimeter and the lowest layer is 0.1 millimeter and has a maximal tensile strength of 3.651 Newton per square millimeter. It can be seen that the thicker the layer, the greater the effect on tensile strength. Conclusion number 2. There is an interaction effect between material type, temperature, and layer thickness on the tensile strength of 3D printed product with PLA and PETG material, supported by the factorial descent above, where the interaction value of the three variable above the p value is less than the value of 0.05. And conclusion number 3, 3D design and product prototypes for an additional hanger for a motorcycle by 3D printer have been made according to the result of the research. Recommendation 1. For the PETG temperature variable in the next research, start with a temperature more than 240 degrees Celsius. In the motorcycle hanger product, it can be seen if you use a 0.3 millimeter layer, the surface results are not smooth. If you want it to be smooth and from an aesthetic point of view, it's good to look at using a thickness of less than 0.3 millimeter. For example, 0.2 millimeter or 0.1 millimeter. Because the smaller the layer thickness, the smoother the surface of the product will be. Recommendation number 3, this is 3D printer is suitable for making prototype, not mass production. Thank you.